Hello everyone. So we're talking about circles still, right? So we've been talking about tangents and radii, and today our focus is going to be on chords. Recall that a chord is a segment with endpoints that are on the circle. Now, because its endpoints lie on the circle, any chord divides a circle into two arcs. So what you can see here, I have the whole circle I have, kind of dotted. The minor arc lies in between those two endpoints, and then you have the major arc, which is the remaining portion of the circle. And you can see I can move this arc or move the chord, and you can see those arcs that are created. Okay, so if we have a chord that passes through the center, that is called our diameter, which then creates the semicircles, right? And then any other chord that's not the diameter, you will find a minor arc and a major arc. So now I have this circle where I created two chords. And we're going to notice something about those two chords. So I'm going to measure them, measure their lengths, and we can see that those two chords are in fact congruent. And we're going to really focus on those minor arcs, those minor intercepted arcs. So the intercepted arc is that arc that lies in between those two endpoints. So we're focusing on the minor arcs. Now there's a relationship that occurs here. If the chords are congruent, we will notice that, in fact, their arcs are congruent. So if this chord of CD is congruent to EF, then we know that arc CD is congruent to arc EF. Now, of course, they're not going to be the same measure because one's an arc angle and the other is a length of a segment, but you'll notice that as I move my chords, see the length of the chord is changing, but yet still staying congruent, and the arcs are changing, but yet again, the minor arcs are still staying congruent. Okay? This is actually a theorem. And the theorem is just as I said. Two minor arcs are congruent if and only if their corresponding chords are congruent. So, and it works both ways, right? Because it's a biconditional if and only if. So in this figure, if we see that segment AB is congruent to segment CD, then we could conclude that arc AB is congruent to arc CD. Okay, so definitely make sure that you copy that theorem down, okay? And again, it works both ways. So if I were to see or be told that arc AB is congruent to arc CD, then we can conclude that segment AB is congruent to segment CD.